It is very important to understand the principle of molecular dynamic simulation. Basically, molecular dynamic simulation is a computational technique used to study the behavior of atoms and molecules over time. The basic principle of molecular dynamic simulation is to simulate the motion of atoms and molecules in a system by solving the classical equations of motion using numerical integration methods. In molecular dynamic simulations, a system is typically represented as a set of particles, that is, atoms or molecules, that interact with each other through a potential energy function. The potential energy function describes the interaction between the particle and determine the forces acting on each particle at each time step. The motion of particles is then calculated by integrating the equations of motion which describe the position and velocity of each particle as a function of time. The integration is typically performed using numerical methods such as Verlet algorithm, which uses the current positions and velocities of the particles to calculate their new positions and velocities at the next time step. To simulate a realistic system, molecular dynamic simulations must take into account several factors, including the geometry and size of the system, the initial positions and velocities of the particles, the potential energy function that describes the interactions between the particles, the boundary conditions that define the edges of the system and how particles interact with them, the temperature and pressure of the system, which can be controlled by adjusting the simulation parameters. Molecular dynamic simulation can provide insights into a wide range of phenomena, including the behavior of proteins and other biomolecules, the properties of materials, and the behavior of liquids and gases. They can be used to explore the dynamics of a system, study the effect of external conditions such as temperature and pressure, and predict the behavior of a system under different conditions. This is all about the principle of molecular dynamic simulation. Thank you.